Hi, good morning. Hi, good morning. Welcome back to the second session of this whole series of the webinar. I see some of the familiar name since the first introductory. So let me get my slide out. Yeah, it's a slide able to see.
Yep, the slides are good.
Okay, so without further ado, welcome again. Today's session we are talking about the molecular testing application. So we putting more on the poultry and aquaculture because we have a huge topic, but we don't have enough time for talking out everything. So just a recap for the last webinar. For those who newly join us, the first webinar actually is the introduction of a molecular platform as a detection tools or testing tools for to be used in poultry and aquaculture. So subsequently, today I was sharing a little bit on the idea on how to use the molecular testing application. So a little bit of introduction of myself. I'm a graduate on Bachelor Science of Biotechnology. I've been in the aquatic disease detection over 15 years. And also I've been consult in setting up a conventional PCR, real-time PCR lab for private hatchery and farm. And myself also a trainer, technical trainer in molecular biology, and also towards the direction of the demand from our customer and client, we involved in the development of the PCR and molecular detection test kit for support the customer need, and also involved in the ISO 17025 certification. So first of all, in modern and advanced farming, the utilizing of molecular tool is no longer just limited to one or two application. I think mostly we know that using molecular testing, we learn about the most straightforward and direct is disease detection. But actually, there's more application from to using these molecular tools. So the whole change of the farming activity from breeding until the biosecurity monitoring and also the finished product, basically the use of molecular tools is more commonly now compared to 20 years back, where the molecular tools is just introduced. So among the, I just give a brief on the molecular tools on DNA, basically tools that analyze DNA or RNA. So here I, throughout the demand from the previous one, I remember there's a participant asking about how to do the analysis or anything. So I thinking of add in some slide on here so that I can just do a brief, very quick one on how to analysis on different platform. So basically, molecular tools here, the most commonly used platform is conventional PCR. Then the second one is real-time PCR, which is currently is more popular now. And also the third one is the imaging. This one is currently is widely applied in the industry now, is next generation sequencing. So for conventional PCR, you can see basically PCR is, I just brief a bit on PCR. PCR basically is, we call polymerase chain reaction, which means that we are targeting certain strand of the desired DNA strand we want to do. Then we multiply it so that we can view the result for the detection or detect certain part of gene for it. So basically, conventional PCR is the most traditional PCR method, which involves in 3 different steps. One step is, of course, is DNA extraction. That will be the same for all the application. Then second one is the PCR process. Then the third one is the gel electrophoresis, where you view the result. So basically, this is the conventional PCR result. You were expecting you will see this kind of result over here. So basically, how to view on this result? Normally, we have a control for it, meaning that you have a no position band. Basically, this light band, white color band over here is basically amplification of the part of the DNA. So it's our target DNA we call PCR product. So basically, the thing is very easy. So when we use one control on it, which means that we know that this is a positive and where's the location of the band we need to determine. Then following the sample, we observe and see whether they are matching the same level with our positive control. So basically, we determine whether detect or non-detect. So conventional PCR basically is a qualitative assay, means that they can only tell you whether it's present or absent. So for real-time PCR, the advancement of this, we can do more things on that. Real-time PCR, talking about this, from the name, you know that it's real-time, means that we actually can see the result on the spot during the PCR is running. So basically, it represents by the graphical method. So where anything that is amplified, you will see a sigmoidal curve. Sigmoidal curve means that it's the S shape of a curve like this. So when there is amplification, you will see a peak like that. So with the use of real-time PCR, we actually can do quantitative already. So basically, we can do more things such as in the medical side, they are doing like drug analysis, everything to see the gene is suppressed or not when doing the treatment. So basically, the point here, when they cross this, we call the threshold. We actually can use that to calculate for the quantity of the gene that is present. So from here, if we talking about disease detection, we'll know how serious of the disease is it, infection level. So the third one is next generation sequencing. So basically, sequencing is the traditional sequencing is basically using the Sanger sequencing, which is they will pair base by base on the target, on the desired DNA we want to determine. On next generation sequencing, basically they are doing multiple alignment over here. So when when the sequence is come up, we need to do bioinformatics on it to align everything together. So this one have contained a wider application, including the variant detection, and also we are using it in other applications such as the genetic breeding and so on. Okay. So I'll give you an overview of how molecular lab is setting up. So basically, molecular lab, you can see things like basically a full complete lab will have extraction room where you process the DNA and RNA, you extract it out from the cell. Then PCR room where you run the PCR, So, and post PCR room for you to run the gel electrophoresis for conventional PCR. Actually, this is our lab in Malaysia. So I just use it to showing, have an idea on what is the molecular lab is looks like. So on low capacity setup, so like research or somewhere else, for example, like this photo is extract from Yuka Hospital, Zambia, where they actually they're using these more compact PCR tools to make up a simple lab for the detection. And also the advancement of the technology, we also have field deployers set up already. So previously, there's a challenge that where the PCR, we need to collect the sample from the field and send to a particular lab for doing the analysis. But now, if it's talking about the disease, this will be a great disadvantage because the transportation time, anytime the disease can be outbreak and the farm getting more serious and serious infection. So the invention of this field deployable setup can let the farmer to immediately test out in case of their suspect of the disease. So now we go into the molecular testing application. So the first application is commonly and widely used is disease detection. So with the use of the PCR or qPCR, we can perform screening or diagnostic on economic important disease. For example, in aquaculture, let's say we talk about fish. So if it's we raise for tilapia fish or the group tilapia fish, for example, currently the most critical disease infection is tilapia lake virus. So from here, why we choose a molecular platform is it able to provide a specific and sensitive test. You can imagine like when we can test on the fish when they have does not have clinical symptom at all, but we can do for that for early detection. So talking about early detection, here is I like to brief a little bit on farm biosecurity. Basically, farm biosecurity is a system that put in place to protect the farm from disease. So it's a preventive measurement. So this make the molecular detection tools like PCR or qPCR is very important because most of the sample involved here is all without clinical symptom. So with the help of these molecular tools, we can enhance the biosecurity in the farm. So basically, how this happen in the whole chain of the culturing period. Basically, before after the fish is spawning, right? We have the fertilized egg. We can actually perform the screening on the broodstock when during their quarantine period and fertilize or after getting the fertilized egg to know that whether they are disease free or not. Because during this stage, if we doesn't test for it, it will be impose a higher risk where the progeny of it carry the virus. As we know, the virus they may not outbreak immediately because the virus has the can be their genetic material can be stored inside the fertilized egg. Okay, so when the incubation period, then only the outbreak, then it will cause a serious loss to the farmer itself. So various application of the molecular tools can be used in this few steps. So during, like for example, after this is happened in the hatchery. After the hatchery produce a fingerling, when the fish fry is ready to go into cage culture or the pond culture, it also can be screened for the presence of disease. If the disease is free from it, then during the culturing period, you will have higher chance of success rate and lower chance of disease infection, because we ensure the stock that you're putting in is clean. Okay, so throughout the grow up level after the harvesting, it also can the use of the molecular tools to check for the disease also can assist in the post-harvest or export requirement, to meeting the export requirement, because certain country now they require for us to do the testing of a disease-free before can import to the country. So this will add the value on it. So this is a disease triangle concept I'd like to share. Basically, just now I was just sharing a part of it, which is this part only. So basically, the utilization of the molecular testing, you also can use on the environment, also can use on the feed. Basically, the whole chain of it, you can apply on it. So in talking about poultry, so there's important disease like Newcastle disease, infectious bursal disease, IBV or IBDV. The detection can be also done using molecular tools, especially when the IBV and IBDV, there are a lot of variant like highly pathogenic group and low pathogenic group. So with the use of molecular tools, we even can construct, after detection, we can do sequencing and construct the phylogenetic tree to identify, to categorize them, whether that, okay, now the poultry, the flock or poultry is infected with the disease. Okay, is fall under high pathogenic group or in low pathogenic group, because the to understand this, you will have better overview of it and have a proper plan for measure for cope this disease from happening. Besides that, another application of these molecular tools is on the vaccination efficacy study. So we know that currently the tools that we use for monitoring during this vaccination program, most of us will choose for the serological testing method to see whether the antibody is being expressed out from the flock itself. So, but if it's, you can combine with this PCR test, they will be have an advantage of it, because we can specifically target the vaccine-specific strain to ensure that the vaccine is already inserted in the flock itself, meaning that the vaccine is inside it's taken in the chicken, and not from the wild strain infection or something, because on serological tests they target on antibodies, so it's still unable to differentiate whether it's the wild strain infection, or is it expressed due to the vaccine? Okay, and also the turnaround time for the PCR detection is fast, normally between 1 to 2 days in our country here. And for serological tests, they can take up to 5 days to come up with the result. So the earlier we know the result, the vets and the farm can have a better monitoring program for it. So another application is genetic breeding. So utilizing tools like next generation sequencing combined with the desired trait selection, we can use these tools to identify the DNA marker and in order to produce a progeny with desired trait. Okay, this is not the comparison for this one, genetic breeding versus the traditional selection breeding. The advantage here is we does not require to wait until the second generation to fully grown to prove that the trait is there. We can use the genetic, we select out the gene that is responsible for this desired trait. Then we can show the percentage of the success of selected the progeny with the desired trait. So among the desired trait is like fast growing, disease resistant, and others. This is a quick overview of how the genetic breeding is doing. So basically the initial stage will be involved in the prediction model training using we so-called as a genetic breeding value. After this, they select the candidate with the genotype. Then after that, they will do parents selection to start from the breeding. Then after that, they cross with the top rank breeding parents to come up with the elite population. Means that they are have the desired trait inside. Then continuously from there to get the stable generation. So the molecular tools also can use to ensure the feed safety. We know that in culturing, in the farming, no matter it's poultry farming or aquaculture farming, the feed is important here. So normally, if we use for pellet feed, generally will be have a lower risk of disease transmission due to the deactivation of pathogen. But some like aquaculture culturing for tilapia, maybe we will use live or fresh or frozen feed to feed to the fish. So there will be chance of those live feed that carry the virus or parasite that will infect the fish later. So constantly we can do the checking on the feed to ensure there's less chance of this to reduce the risk from the attack of the disease. So another application on this is on the feed ingredient content analysis. We know that certain countries they have regulation that the feed is prohibited from contain. Let's say like some country cannot contain cattle inside in the ingredient. Some they cannot tolerance on the pig, like in Malaysia, because due to the religion purpose, the feed is prohibited from contain the porcine content inside. So the screening of raw material for this authenticity can be done using the molecular tools. And also another one is currently there's more and more utilization of probiotic in mixture with the feed. But how we can ensure that the probiotic is not contaminated or there's other undesired bacteria is grow in the probiotic culture. We also can use the molecular tools to analyze it. So this is an example of one of the probiotic product that is using in aquaculture farming. So you can see most of the probiotic contain lactobacillus, but beside this, you can see there are portion of streptococcus is coming in also. So these have potentially, like, we are trying to get a healthier fish by providing the probiotic, but actually we are inserting, if we don't test for it, we actually introduce pathogenic bacteria inside as well. So on food safety side, because in poultry, we are always happening that you from the news recently, the rejection of the egg due to salmonella infection. If we have a monitoring program from the beginning, then we can prevent this from occurrence. And also for the pre-export testing for uncooked prawn, currently in few countries like Australia, Korea, they have demand that they must be disease-free, certain disease-free from the prawn itself. So this only can be done using molecular tools. So the latest application here, recently I have read in some article on the animal health. They even utilize the gut environment microbiome study to ensure the animal is healthy. So basically, how they do is they use they extract the gut of the animal and do a bacterial profiling to compare between healthy and unhealthy. So they found, in order to find a population of the bacteria inside, and use that to predict this animal have a potentially health issue or not. This same goes to the environment. Here I show you an example for the shrimp aquaculture pond, where recently there's a attack of I'm not sure you have heard before, we call EMMSAR. EMMSAR basically is carried by the pathogenic Vibrio parahemolyticus, where they contain these EMMSAR plasmid inside the bacteria, and they tends to release toxin to kill the shrimp. So basically, when we do this gut and environment monitoring, you can see this green color is under Vibrio group. So you can see this is a control with a positive detection of the EMMSAR. So you can see the Vibrio content is this much. And from the pond water, this is pond water. You can see the presence of different bacteria inside, but this is a Rebio group. And we also compare it in the hepatopancreas and also the gut. So basically, when we this show that the traditional method, like traditionally how we do the Rebio detection, we using TCBS plate. Normally we spray on the water. So when you spray on the water, you can basically see the Rebio population here is in the animal itself is at least double to triple of the environment. So if it's like we can do utilizing these molecular tools, we can know that basically is quite early detection of it. It is like quite serious happening already. Even when the environment sample we are unable to is showing like normal. So in summary, application of molecular technique in aquaculture and poultry farm, we can use molecular technique in disease screening or diagnostic, vaccination efficacy, genetic breeding, feed safety, food safety, and also animal health. And I believe my example of application is not just limited to this field only. There will be more and more application because the molecular tools is very wide, the application. So my sharing is come to the end. I think thank you for your attention. If you have any question, you can drop me email or can contact Dr. Adebayo also. I think now I pass back to Josiah for we open up for the Q&A session.
All right, thank you, Leon. I appreciate it, and that was great sharing. Yeah, I think there are a lot of concepts and ideas that were shared. There are some questions, and to everyone else who is listening, all the participants, feel free to drop your questions in the Q&A area as well, and then I will read it out for everyone, and we'll get Mr. Leong's opinions, thoughts, and comments as well. All right. So I'll just read this question from Solomon. Thank you, Solomon, for the question. So he is asking about the deployable field PCR. How accessible is it? And maybe you can talk about how does a field deployable system compare to actually a lab, like an actual diagnostic lab. And then if you know how accessible is the technology compared to, well, in Nigeria as well. So I think that's one of the questions. So there are three parts to it, right? How accessible is the field deployable system? And then how does it compare if you use a field deployable system versus sending a sample to the lab? And then what about the application in Nigeria?
Okay. Hi, Dr. Solomon. So to answer this question, deployable field PCR. Basically, this deployable field PCR tools, right, is basically a portable PCR machine. Currently, the version come to it is like a size of a handphone, size of as small as a smartphone only, and is battery power, and it basically remove the barrier of we need of electricity, need of a proper setup to do it. But So this deployable field PCR for the time being is doing for qualitative assay only. So when there is an emergency, or because you know that during the disease outbreak or something, the distance of the faster we can know the result, the better for us to do the treatment or make the decision to either is harvest or you want to kill it or any other action. So the use of this deployable field PCR is, the purpose is here. So most of the cases I encounter here on the private farmer, they are using this one. They basically, after they know the decision, know the result, they didn't send the sample to the lab because the practical method is once they know the result, they will do the immediately action treatment, unless there is the situation where in Malaysia here, we mostly doing pond culturing. I think in Nigeria, there's a mix of pond culturing and also cage culture. So pond culturing, they will also select the adjacent farm pond for the sampling to, maybe they want to do a further analysis, they will send to the lab. So basically, to send to the lab is to have a more confirmatory purpose. And the field PCR is more on the quick testing, because a field PCR, you can know the result in about 40 minutes like that. Okay. How accessible is this technology? I'm not sure you have seen these tools before or not, because these tools is basically come from Taiwan. I'm not sure. I'm not really sure. Maybe Dr. Abdibayo can help me with this, whether he's seen these tools before or not. Yeah.
Yeah, sorry, I think I missed the question. If I can have access to the question, maybe I can help.
Yeah. I think the question is whether these portable based tools is already available in Nigeria or not.
Oh, okay. Yeah, so you're right. There are some of those tools that are actually available in Nigeria, like I mentioned last week. I think it's just that it's limited. And that is the reason why we are trying to find this opportunity and make good use of it. So some of them are actually available and some of them are also ready for imports, but they can also be quite expensive. So that is one of the things that's been a discouraging factor to many people that may want to even venture into it. So, but regarding the availability, yes, there are a couple of them that are available and some are also ready for imports. Thank you.
All right, great. Thank you, Dr. Adibayo, for the input. Dr. Kadar Ali Said, you have your hand raised. Would you like to speak? We'll allow you to speak if you'd like to. Wait, okay. So nothing yet. If that's the case, I will just move on and wait for you. If you want to type in your question, Dr. Kadar, please feel free to do so. I think we have a couple more questions, great questions, people. Hamza Idris Gital, right? So how does the time interval between sample collection and sample processing affect the sensitivity of the results? Is it significant enough to alter the results? Great question.
Yeah, thanks Hamza for this question. Basically, the time of the collection, the sampling is actually a critical issue. We let's say for example, we need to see what are the purpose of the test first. like let's say you are screening on the healthy population. So normally you will be sampling the physically healthy population from it. So we have a technique where you are doing either random sampling or you are doing the bias sampling. So normally for increase the sensitivity or capturing of it, we more recommend to do the bias sampling because in assumption of a healthy population, if we able to sampling those weak individual and doing the test for it, so there's a chance the weak population that will contain the disease rather than the healthy one. So on the another things that will affect the sensitivity of the result or the accuracy of the result, in more accurate way to say, is the preservation of the sample. So for molecular detection, the sample, because we dealing with DNA or RNA, so we know that once the individual had died or the sample is being extracted, like organ is being extracted out, the cell itself, they will kick in the lysis procedure. Basically, the enzyme inside the cell, they will start to digest things, especially the DNA. So after the sampling of the organ, you need to immediately put into the suitable type of preservative. Like for example, here I can, for the PCR analysis, normally we store in 95% ethanol or RNA letter to immediately inhibit the enzyme from go to destroy the DNA or RNA. So with this kind of practice, basically you can ensure the sensitivity of the result. And also the third thing is the sample condition. Basically, what we say sample condition is like during the outbreak case, like if you want to do diagnostic, it's outbreak already. So we select those physically like more towards just dying instead of already die for a long time. Because die for a long time, the same principle is going to the same. The enzyme itself is started to digest and destroy the DNA. Thus, sometimes you cannot get the accurate result is from there. Okay, I hope this answered the question.
All right, great. And then we have another great question from Yargin Nama. I believe this person was here last week as well, so it's great to have you here again. The question is, please could you explain further on regarding fish feed that contains probiotics? Is there some malhandling of the feed that could lead to disease condition in fish? So just now, I think you were talking about how feed could be a vector of disease transmission. So how can probiotics and feed be a vector? And why are these vectors?
Yeah, this is one of the example I just showed just now. Basically, probiotic, especially for if you're using the liquid form, because the liquid form probiotic, basically they are enrichment media inside. So if it's accidentally contaminated with the pathogenic bacteria inside, they will also grow and multiply inside the probiotic itself. So when you feed to the fish, they will lead to the disease, potentially lead to the disease outbreak if they contain the the pathogenic bacteria inside. If it does not have, then it's okay.
Thanks.
I'm not sure the MAL is what are the meaning.
Oh, I think it's more malhandling. So like, is it bad production practices? Like how, so like you mentioned, right? That probiotics, because it's a liquid probiotics and enrichment media, I think is how does an enrichment media get contaminated, right? So that would be mostly bad manufacturing processes, bad production processes, I guess.
Okay. Understood.
Right, great. Thank you for the questions. Do we have more from the audience? No? Great. So I think we will cap it here then. Thank you everybody for joining us today. And Dr. Adebayo is back with us right now. So it's great to have you, Dr. Adebayo.
Yeah, thank you, Josiah. Thank you
Yeah.
very much. And thank you for holding forth. Hi, everyone. Nice, the great presentation. I was actually partly following. So, yeah, so because I didn't want to miss any part of this great training. So thank you very much for, and also for the answers to the questions. Yes, very profound. Really appreciate that. Thank you, Josiah, for holding forth.
Yeah.
You've become a very great moderator today.
No problem. Thank you. Yeah, I will just to conclude, and then I'll actually pass it to you, Dr. Adebayo, for any final thoughts or comments. So thank you again.
Okay.
This is session 2 of kind of our 3-part series. We will have one again at the same time on Wednesday next week, and we will be ending with Mr. Robin, who will be closing kind of the sessions out. Somebody just now asked in the chat whether the webinars and the presentations will be made available. The answer to that is yes. Please give us some time to kind of collate everything at the end, and we can send all of it to you in one shot. So even if you missed session 1 and you're here for today and the next one, you can still get access to session 1 as well. All right, so don't worry about access to the slides and or to the webinar. We will make that available to you all, right? So we're looking forward to having each one of you next week as well. And I think hopefully you're starting to see this abstract to practical and concrete thing. And maybe if you're thinking as well, how would you like to get started? How do I get started with this? The next session is going to be for you. All right. So that is my closing pitch, I suppose.
I think there's one more question.
Oh, there's a few more questions. Yeah. Oh, okay, great.
Yeah.
Okay.
So it's from Suleiman. So, okay, differentiate between contaminant from lab and real pathogen while running sample, right? Okay, this one normally this one I can say that unfortunately you might not able to differentiate it, because when there is a contaminant inside the lab and is accidentally go into to your sample, then potentially you will get contaminated. Means that it's a false positive result. But this is the risk we need to live along during the lab procedure. But there is certain ways for it to prevent the contaminants from this situation happening, including that using a minimized step that will create error, then using some critical point control measurement. This is like to prevent that's the point that some step is more prone to have a contaminant issue. we use this critical control point to prevent it from happening. So this is some practice in the laboratory to reduce the chance of contamination from the lab. We name it this as a technical error. So we only can reduce until very low, but it's not zero. Normally, also the use of replicate of a test, you also can achieve this from prevention of this contamination from occur. Okay. Hope this answer the question.
Great, thank you, Leong, and thank you, Sulaiman, for the question. All right. Yes, I was just about to pass it over actually to you, Dr. Adebayo, for any closing thoughts. And then if not, you can dismiss this after.
Yeah. Thank you very much, Josiah. Great answer there, Mr. Leon, because I was about to say from my years of experience in the laboratory, it will be very hard for you to differentiate between contamination and the real pathogen, but you just have to look at all the critical control points and ensure that you have not missed any part of the step, and the accuracy also in all of those procedure or protocol. And it's not a sin to have your procedure right in front of you every time you are running the assay to be sure that you are doing the right thing. So don't be master like you are master now and I don't need my SOP. So always have your SOP in front of you whenever you are running your assay, and make sure you clean up before and after your experiment. Every time you finish, every time before you start, make sure you clean up. Those are some of the things or ways in which you can reduce contaminants from being in your assay, so that you will not be in doubt of whatever you are getting. Thank you very much, everyone, for participating in this training. It's been a very great and enlightening one. And thank you very much, Mr. Leon. And Josiah, thank you very much. I'll still have to come back to you for holding forth.
No problem,
So
anytime.
I really appreciate every one of you. Remember, we are going to be having a grand finale next week. For some of you that have just participating, you can see that we are moving from abstract now to practical, and it is becoming really, really real. And it's going to be getting better by the time you come next week. You're going to now see the big picture and some of the plans that we also have for you. It's great having you all on board. And next week, the same time, we're going to be meeting here for the final episode of this training session. And then you're going to hear how we go from here. Thank you very much, everyone. And bye for now.
All right, thanks, everybody. Take care.